sun. These enter photosystem 1 and 2 at the same time, but right now we'll be focusing on photosystem 2. So once they enter photosystem 2, they bounce around upon the chlorophyll pigment, and there's basically a bunch of these in the photosystem 2. So as you can see, it just moves around. And 2 electrons are taken from water molecules, and they're charged up using the photons. And this is moved to the transfer proteins. And while it moves across the transfer proteins, it opens up a channel which allows more hydrogen to flow into the space. And this happens over and over with each photon coming through. With the hydrogen that went into the space, it just gathers up, and this is used for ATP synthase and as a production, or to produce ATP from photosynthesis. And here you can't differentiate the colors between phosphorus and hydrogen, but on the bottom it's ADP getting a phosphorus added. Alright, so like I said, there's photosystem 1 and 2, and this is 2. The electrons that are, or photons that are all worn out, go to photosystem 1, that's supposed to say 1, to get recharged, and they get recharged and put into NADP, an electron carrier, and you have ATP and NAD made at the end of that. Then we move into the Calvin cycle. Don't make noise. Alright, so you start with ribulose 1,5-biophosphate, and that combines with carbon dioxide in the carbon fixation stage, and that creates 3 phosphoglycerates. And this essentially moves down and binds with ATP to make 3 biosulfoglycerate. And then these NADPH is brought in reduction to the molecule, and this turns it into G3P, known as glyceraldehyde 3-phosphate, and NADPH is reduced to NADP+, and you get an inorganic phosphate floating around. So with the rest of the G3P, only 1 is used or taken from each cycle in the Calvin cycle, because the 5 other ones are needed to reform ribulose 5-biophosphate. And so what happens is those go back into the system, and they take an ATP and are together again.